All right. Hey, what's up, guys? I got number 31 today from your section 6-1 problem set. Now, if you didn't stay after class, I'd already kind of explained my approach to start a problem like this, but that means that you didn't hear number 31. So, anyways, number 31 seemed like it was the most blank kind of on the homework when I was looking at them earlier. So I know that there are a bunch of people struggled with this one, right? Because there's a lot of stuff going on with square roots and whatnot here. And let's just face it here, right? When we have an altitude drawn to a hypotenuse of a right triangle, there's a right triangle right here. It can be kind of hard to make the parts fit. Okay, so what I'm going to do is go through it again in case you didn't. I did go over it third, fifth, and seventh after class, but I'll go through it again now. Happy to do that for sure. And I want you to remember the thing that I know you heard because I did it 5 minutes before class ended, right? A full 5 minutes talked about it, how I'd approach a problem like this at the beginning. First of all, what am I looking at right away? I'm just looking at these three. That's all I'm looking at. Again, this side, the reason I'm going to look at these is that this side is the geometric mean between the segment of the hypotenuse that it's adjacent to and the entire hypotenuse. This here, this leg here of the large right triangle is the geometric mean between this segment of the hypotenuse and the whole hypotenuse of the large triangle here. And finally, last but certainly not least, my favorite of the geometric means here is the altitude itself, is the geometric mean of that part of the hypotenuse and that part of the hypotenuse. Okay, so geometric thing, like the hypotenuse all connects to these here, right? The hypotenuse all connects to those three. Geometric mean of that and that, the geometric mean of that and that, geometric mean of that and that. Okay, so don't look at the hypotenuse right now. Think about which of these geometric means is going to get us to an equation where we're only going to have one variable. Okay, and so we can look at this now. Y is the geometric mean of x, and well, whatever the hypotenuse is, we'll get to that in a second. We're not going to want to do that because y to x, we have two variables in our equation, right? Y to x is the same as x to whatever the hypotenuse is here. So it's not going to work. Okay, same thing with the altitude here. Altitude, z is the geometric mean between x and root 2. Well, then we would have z and x in an equation here, and that would be no good, right? Z is the geometric mean between x and root 2. Well, hey, we can't solve for, we get z squared equals x root 2. And we're not going to solve for it, right? Because we would have two variables in the equation. Okay, so we're not going to want to do that. That means that kind of this one over here, 2, fingers crossed, or else this is a ridiculously hard problem. Fingers crossed is that the side length of 2 is going to be the key trick to get us there to at least solve for potentially x, right? Because x is part of a hypotenuse here, okay? 2 is actually not the geometric mean between x, though, right? Because x is this segment over here. It's between root 2, okay? 2 is the geometric mean between root 2 and, well, we don't know it's down here, okay? This is potentially going to be an unknown that we'll solve for here, but we kind of do, okay? So 2 is the geometric mean between the segment of the hypotenuse that this leg is adjacent to, which is 2, but then also the entire hypotenuse, okay? So this is potentially the first place where somebody might get stuck at this point here, is what's going to go there, okay? 2 is the geometric mean between root 2, well, I know that's here. What do I know? This is my question mark here, is what do I know about the whole hypotenuse? Segment of the hypotenuse is adjacent to, and the whole hypotenuse itself. That's what 2 is the geometric mean of, okay? And here, right, through the segment addition postulate, right, we know that this portion of the segment is length x, that portion of the segment is root 2, so this is it. It must be the sum of those two, okay, the sum of those two add together. So your hypotenuse can be represented algebraically, given this algebra that we have down here, this variable and then this root 2 right here, as the quantity x plus root 2, okay, x plus root 2. And you might be asking yourself, is there a way I can simplify that to make my life a little bit easier for the next step? And the answer is no. So x is a variable, and root 2 it's an irrational number, but it's a constant. It's a constant term. So these are unlike terms, right? I don't see x over here, right? So I can't add it to this x right here. So anyways, I'm going to leave this as x plus root 2, and now the fun begins, right? The fun begins. Fun police is coming out here. It's going to make you do this here. What are they going to make you do? We're going to cross multiply. Okay, we're totally going to cross multiply this. Right, that's how I'd set up all these here. You can even use that geometric mean shortcut that I showed you guys earlier in class. But anyways, let's go ahead and cross multiply. Stay with the same process here. Don't overwhelm ourselves too much. 2 times 2 equals 4. That's the easy part. Harder part's going to be this, and maybe I'll show it to you in greater detail than what I did after class today. Root 2 times by the quantity x plus root 2, okay? So here, we got to take this, we're going to cross multiply this, and then, hey, we got 2 terms down there, right? This is not a binomial, but it is 2 terms. That doesn't fit the definition of polynomial. Anyways, root 2 times by x plus root 2, we're going to have to actually distribute this, okay? We're going to have to distribute this into the parentheses. We'll have to distribute. And that could be a little scary, right? I haven't done too much distributive property of multiplication over addition this year, but hey, you've done it in the past, right? That's why you're coming to me, having done a little algebra 1 action. Yeah. Okay, so check it out here. Root 2 times by x. You might be wondering what I can do. Well, this is 1 root 2, and now we're multiplying it to x. That means we have root 2 x amount of times, right? X amount of times. So if I multiply root 2 times, say x is 5, root 2 times by 5, I would have 5 root 2s. If I multiply root 2 times by, let's say x is 10, I'd have 10 root 2s. Okay, if I multiplied it by x, I would have x root 2s. Okay, so I'll show it out like that. This is how I write this out. What would technically be correct you could have written it out this way, root 2, and then the x on the outside parentheses. That's very dangerous, though, when you're doing problems like that, because you might think that that x is underneath the square root symbol. Okay, see that? I just pulled it here, made it a little bit further. So don't write it like this, right? Teachers will never tell you to write it like that. Write it like this. Root 2 times by x is the same thing as x times by root 2. Okay, so what I'd say verbally, I'd refer to that as x root 2, just as I would 5 root 2 or 10 root 2. The multiplying is implied there, right? Is x is multiplied to root 2, and that's as much as we can simplify it. Okay, we're not going to change up what's inside that square root here. Okay, next up we have square root of root 2. We're going to multiply to root 2. And here you might be like setting up your rectangle if you do rectangle multiplying and realizing that root 2 times by root 2, well, this is a root of a square, right? A root of a square. Root 2 times root 2 just equals 2. That's where root 2 came from, as a matter of fact. Square root of, so if I have a square and its area is 2, then base times height is going to have to be the same number. What number is that? Well, the square root of 2. Square root of 2 times square root of 2. So the square root of 2 is technically something called an irrational number, and we're kind of getting a little off track here. Let's see, we pull you guys back on track here. 2, if I take the square root of it, it's this crazy irrational number. It's non-repeating and non-terminating. Here, like these digits are just kind of random, and then my calculator can't go on infinitely, so it kind of ends here. But it's approximately 1.41, 4213. It's approximately that. So where did this number come from? Well, there's no perfect number that when multiplied to itself becomes 2. If I take, for instance, 1.4 and multiply it by 2, I get 2.8. If I take 1.41 and multiply by 2, I get, the heck, 2.82? Is it really that big of a difference here? 1.41 times by, times 1.41. 1.41, I get 1.9881. Okay, what I should have shown you a second ago was if I do 1.4 times by 1.4, right? 1.4 squared, I don't get exactly 2, okay? But if I keep going closer to what our approximation is of the square root of 2, I get pretty close to 2, pretty freaking close to 2. There's no perfect number here, okay? So that's the point of the square root of 2, is that it's possible for something to have an area of 2, right? If we each have 2 units and we break it out into a square, then this is square root of 2 here, this is square root of 2 here, okay? So my whole point of this is just to remind you that a square root simply tells you the square root of a number is the number that when times itself is that number. Okay, so then the question is here, if I'm doing here, if I'm looking at this, square root of 2 times square root of 2, if I do that, square root of 2 times by square root of 2, what's my answer? Well, it's just 2. It's just 2. This is the number when times itself is 2. The definition of square root is the number that times itself is that number. So this number times itself is 2. Well, here we have that exact situation. We got the square root of 2 multiplied to itself. So the answer here is 2 for that, okay? So maybe that tripped up some people here. Okay, we're getting closer. There's actually kind of a lot of steps you might have gotten tripped up on here. Now we have root 2 x amount of times, whatever x had to be here. And now we have root 2 times root 2. Well, that's just 2. We're adding 2 to that x root 2. It's equal to 4. So that here we can deduce, we can take away this 2, because if we had x root 2's and we added 2 to it, we got 4. Well, and what if we didn't add the 2's there? Right? Let's get rid of the adding 2's here. Well, then x root 2 would have to be equal to 2. Right? Here, this is 2 plus 2 would equal 4. So x root 2 is 2 right here. Okay? Next up to solving, because I want to isolate x, right? You're getting some good practice with square roots here. That's what the next week will be. We have a decent amount of stuff to do with this here. So a little bit of a heads up. So what you're going to have to do to isolate x now, well, I have x root 2's. So that must mean I have root 2's of many x's, right? Remember, timesing can go both ways. Timesing has the commutative property, it's called. So if this could be thought of as we have root 2 amount of x's, right? Because we take x and we multiply by root 2. We have that many of them. To undo that, I simply have to divide both sides by root 2. Okay, divide by root 2 here, and this is getting messy. Okay, root 2's cancel out. That's not a problem there. We canceled out. We became a 1. And so now we have something that I was expecting a lot of people to say is the answer. But I think you guys maybe looked at the back of the book, which is a good strategy, and you were like, how did they get that? And the answer is, I haven't taught you the rest of this yet. So I'm glad you saw it. I'm glad you grappled with it. Sorry if it stressed you out. But hey, we got to keep being curious and keep making connections and keep pushing ourselves forward. You don't need to get everything right, right? It's totally good if you just give your best shot and you watch videos like this. Be like, oh, I get it now. Nice. So claw your way there and you got this, okay? So anyways, I haven't taught you how to do this yet. What we need to do in this situation is something called rationalize the denominator. Okay, the denominator. Probably don't know a lot of what those words are. You know what denominator is, right? That's like the bottom of the fraction, right? This is the numerator, that's the denominator. Rationalizing it, square root of 2, again, I told you, right? Square root of 2 is irrational. Okay, it's irrational because it's non-repeating. Okay, the decimal, if we look at square root of 2, it has no pattern. It doesn't repeat at all, right? It doesn't repeat at all. And it never ends, right? It would keep going forever. This calculator can't show me that, but it does keep going forever. And that's going to be true for any square root of a number that's not a perfect square, okay? So if number's like 9 has a square root, and that's 3. It terminates at 3. Like there's just zeros after that, right? 3.0 forever. So we say it terminates at 3 or repeats with zeros, but whatever. That's something called a rational number. A rational number. If we can't take the perfect square root of a particular number, then it's going to be an irrational number. They're basically, like, humans needed to invent numbers that when multiplied to themselves would equal a counting number like 2, right? What times itself is these 2 fingers here, or like about 1.4 fingers or so? We'll call it square root of 2. That's the exact number, right? There's the only way to get the exact number is to write it that way, okay? So the reason for this, you'll see this in the video. The guy explains it for you in this video. The reason why we can't leave this here, we can't leave square root 2 in the denominator, is because it never ends, right? It never ends. It goes on forever. It's not a clean number, right? Not a clean number. So technically, right, what a denominator, like a fraction bar represents division. So how could you take 2 and divide it by a number that never ends, right? That's irrational. Well, you can't divide anything cleanly by a number that never ends, that we don't know exactly what it is, right? We can't prove that exactly what it is. So the rule is can't have this, right? Can't have this. Rationalize the denominator. It's currently irrational. So here's how you do that. Okay, this will be in your lesson video. You got that 4-minute guy video, explains it. There's also another video from Saul Khan. I think he goes through it. The other video from the MIT grad lady there, it's like an 18-minute long video. They'll go through it. The way we're going to simplify this, okay? The rule on this one here is we're going to multiply. The way to do this is this. We're going to multiply both sides by 1. Okay, by 1. Or we actually just have to multiply the left side by 1. Because if you multiply a quantity by 1, right, say I have 50 and I multiply that by 1, what's my answer? It's 50. If I multiply any quantity by 1, the number is unchanged. Okay, number is unchanged. So the number 1 is the only number where I can multiply to a side of an equation. Like if I just multiply the 1 over here, it's not going to change this. It's still going to be equal to 1. Right? It's still going to be, it's still going to be equal to x. X times 1 is just still 1x, right? We say one of them. So you can think about this as multiplying both sides by 1, or it could be multiplying just this left side here by 1. But here's how I want you to multiply by 1. okay? 1 actually equals, it's equivalent to this. This is what you're going to do for this one. We're going to take that denominator, square root of 2 over square root of 2, and that is equal to 1. Check it out. That's equal to 1. It's 1. It's in disguise. It's in disguise, but it's still 1. Why do I know that square root of 2 over square root of 2 equals 1? Well, because anything over itself. Okay, sorry, yeah, anything over itself equals 1, because anything divided by itself. If I have X dollars and I divide that to X amount of people, everybody gets $1, right? If I have $50 and I split that to 50 people, everybody has $1. Okay. If I have root $2, right, 1.41 cents, keep going, a little more change than that, $1.41 that is, and I split it to root 2 amount of people, right? The 1.4 people are there. It makes no sense, but we get $1 each. So this is the way to do it. And here, now that I'm multiplying this root 2 of root 2, again, doesn't change the quantity that's over here. So we know that this equality is preserved. What's going to happen here is that this is going to be root 2 times 2. So I end up with 2 root 2 over, and then here we got the same situation again here. Root 2 times root 2, well, that just equals 2. So I'm going to put that equal to over 2 here. And now that's still equal to X. Right? The X is unchanged here. Okay, so now X, now we're simplifying to a little bit closer to what the answer key was in the book. What's the next step? Well, here I have 2 root 2s. You treat the roots, like you treat the radicals, just like you treat variables. Here's 2 root 2s. Like you could have 2 Y's or 2 Z's or 2 A's, right? That kind of thing. So if I'm splitting that 2 A's, I just have one of each of those variables or things left. If I have 2 root 2s, split 2 A's, that's just going to cancel out. I have 1 root 2. Must be what X represents here. And there you go. You have it. Maybe you're done watching the video. Maybe I'm dropping the mic. But hey, maybe watch the video for the rest of this here, because some of this other stuff could be confusing. Let's go back to the diagram right here, guys. Let's go back to the diagram. So this now becomes root 2. And what do we notice here? Ooh, interesting. I make an observation. Check it out. What am I pointing out here? Root 2 here and root 2 here. Interesting. Okay, so this altitude actually goes to the midpoint of the hypotenuse. I mentioned this in one class today. I'm assuming people didn't really figure out what I'm going here. Root 2, this is root 2 here. If X is root 2 right here, and here, right, the length of the hypotenuse is root 2 plus root 2. So this is going to be 2 root 2. Okay, 2 root 2. I got 2 of them. This root 2 plus that root 2 gives me 2 root 2. That gives me the hypotenuse. That might help me get Y. Right? That might help me get Y. That might be the thing that I do next. But one other thing that I wanted to point out here is that root 2 is here, root 2 is here. That means this altitude hits the midpoint of this hypotenuse, right? Because this distance is the same as that distance, this point here, which created that distance, and this point here, which created that distance by simply hitting the point here, it bisects that segment. So that means it's a midpoint. So we know that this is actually congruent to this. This is a right angle, okay? So this is a right angle. And then here, this side is congruent to itself. So this triangle is actually congruent to that triangle by SAS. SAS, okay? And by CP/CTC, this is 2. What else is 2? Y is 2. There you go. Y is 2. You could have solved for Y equals 2, though, by geometric mean stuff. So maybe I'll model that as well for you here. Y is the geometric mean between root 2 and the hypotenuse, which is 2 root 2. All right, so you just set it up, and you're doing it the same way. Root 2 times 2 root 2, again, you kind of treat your square roots as kind of variables here. This is 2 times by root 2. So if I'm doing that another root 2 times, I would have this, right? 2 times by root 2 times by root 2. Well, this I can just make 2. Okay, so this would equal 2 times 2, so that equals 4, right? Root 2 times root 2 becomes 2. Multiply by another 2, we get 4. Okay, so cross multiply here, right? Cross multiply this, cross multiply that, y squared equals 4. What do we know about the square root of 4? Well, again, we're just looking for positive values here too, because this is geometry and this needs to be positive, right? So 4 does have technically 2 square roots, 2 and negative 2, but we don't have to worry about that here in our classes here. So we take the square root of 4 and we get 2 for y. There you go. We get 2 for y. This is a hard problem. This is tricky. But hey, we get another day problem set, right? You see it, struggle with it, keep pushing forward, keep getting it here. It's starting really hard at the beginning of the week. I think it'll ease off hopefully towards the end of the week here. Okay, y is 2, x is root 2, z. Another thing I wanted to point out here, beyond the SAS thing right here, there was another theorem that you guys learned. You did. Related to this here, because this hits the midpoint of the hypotenuse. This altitude, sure, it's perpendicular, but it perpendicularly bisects this hypotenuse. But because this actually bisects the hypotenuse here, this is technically a median drawn to the hypotenuse, okay? We know that the median drawn to a hypotenuse of a right triangle is equidistant. The midpoints would be equidistant from the 3 vertices of the right triangle, okay? We know this because if we doubled the size of this right triangle, we'd end up with a rectangle, okay? And a rectangle's diagonals are congruent, and if your rectangle, your parallelogram, your diagonals also bisect each other. So this would be 2 up here, this would be 2 down there. Root 2. Root 2 is our answer here. Root 2 here and root 2. So there's the answer, okay? Could you do that through setting up proportions? Yes, of course you could, because z is the geometric mean between the 2 segments of the hypotenuse it creates. And we'll see here, it's all about just connections, right? There's so many ways we can solve problems. It's kind of freaking cool, okay? Root 2 times root 2, well, that just equals 2. Z times z is z squared. How would we isolate z? Well, we take the square root of both sides, and we'll say that z equals the square root of 2, approximately 1.41, okay? There's my video. There's number 31. If you watched all 4 of these videos, thank you, man. You're pushing yourself hard. Hopefully, keeping in mind some of the things, some of the principles that, hey, start away from the hypotenuse. Don't think of the hypotenuse right away. Hopefully that helps when you do this problem set on Thursday, okay? Now that you're going to get more practice using square roots in today's homework, perhaps a problem like this will be a little bit more understandable in terms of the steps you need to take, okay? But to summarize this, z equals root 2, y equals 2, and x also equals root 2. Hopefully you saw my logic. Thanks for watching. Take care. Bye.